Alright, hello students. This video is about recursive sequences. So let's look at this sequence right here. So first we notice that this is in fact a sequence and not a series. Alright, we know that series are separated. By addition signs where things are being added together, whereas a sequence is separated by commas. So here I have a sequence, and this sequence continues on forever, right? Continues on and continues on, and it'll eventually get to 292, 295, 298, and it continues to go on. Let's name the parts of this sequence. Okay, each of these is called a term. So here we have the first term, and we're going to call this term A1. So here we have A1, the first term, and the next one is A2, and etc. A2 for the second one, A3, A4, and they go on and on like this, right? Now let's say though that instead of talking about, let's say instead of talking about a term that I know, like the third term or the fourth term, what if I want to talk about a general term in the middle of the sequence? If I want to know any old term in the middle, since I don't know which term it is, I just put in. So AN is the general term. Okay, now if the general term is AN, then if I go down one number, then the previous term that came before that would be N minus 1. So N minus 1 means the previous term in the sequence. And then N plus 1 would be the next term in the sequence. Alright, so now we're talking about these recursive sequences. Okay, what does it mean for a sequence to be recursive? Alright, so recursive means that something is relating to or involving repeated applications of a rule. So recursive is relating to or involving repeated applications of a rule. So in our sequence, what's the rule? Okay, what's the rule for our sequence? All right, well, it looks like the rule for us is just add 3, right? Negative 5 plus 3 gives us negative 2, and negative 2 plus 3 gives us 1, etc. And each time, we can find the new number by just adding 3. I know that if I'm at 1, I can write a rule that says that 4, my next number, equals my previous number, which is 1, plus 3 more. So this is a rule for my formula. I have the new number equals the previous number plus 3. Let's see if we can say that in terms of these. Okay, I could say that my new number, if I let my new number be a to the n, a sub n minus 1, if I let my new number be a n plus 1, then that would equal my previous number plus 3. Okay, so we can write this in terms of the new thing, the next number. And sometimes in the literature you will see it written like this. Most of the time in our class, we're going to write these in terms of AN, to equal AN instead of equaling AN plus. What does AN equal? AN equals the previous term, AN minus 1, plus 3. Okay, so these two formulas are saying the same thing. This is the one that we're going to use in terms of AN, but just so you know, you can also write the formula in terms of AN plus 1. So at this point, maybe some of you are beginning to sense a problem, saying to yourselves, well, isn't this whole thing a little bit circular or redundant? If we just keep on adding 3 each time, when are we going to get to an answer? Like, how are we going to ever know when to stop? I know that the 15th term of this sequence is 37. Okay, well, 37 minus 3, 34, minus 3, 31, and I just keep on subtracting 3 and subtracting 3 But how do I ever know when to stop? Can't I just be subtracting 3 forever? Okay, or a similar problem. Right now we have a sub n equals the previous term plus 3. So, if I'm at 22, I can just add 3, 25, add 3, 28. So you might just say to yourself, okay, the whole sequence is just add 3. Okay, so sure, you say, you're just adding, the whole thing is just add 3 each time. All right, but what about your friend who starts at 8 and starts adding 3? 8, 11, okay? And wait a second, after a while you go, wait a second, we're not getting the same numbers, okay? What's the problem? This person has started in the wrong spot. So the place where you start matters. And if you don't say where you start, you don't know when to stop counting. It goes on forever. So this is not quite enough information. We also have to say, in order to stop this process, there must always be one value that does not depend on the other values. Okay? There always must be one thing that does not need anything else. One term must stand alone. And so we need to say what that first term is. And for us, our first term is -5. So a recursive sequence has to have both of these parts. Okay? Both of these parts are important. We need to say what the next term is doing, but we also need to say where we're starting from. So now we come to our exact definition of what it means to be a recursive formula. A recursive formula always has to start by designating a starting term, like our A1 here, okay? It has to say where to start. That starting term is A1. And then the recursive formula has to tell you the nth term of the sequence, how to find the nth term of the sequence. And so it's going to tell you how to find the nth term. And that nth term is going to be expressed, and that nth term is going to be an expression containing the previous term. And the previous term is a to sub n minus 1. So that's the definition of recursive formula. Let's go ahead and look at some examples of finding the recursive formula for sequencing. All right, first example, let's see if we can write the recursive formula for this sequence. So when I look at this sequence, one of the first things I notice here is that every time it's going down by 8. Okay, I could do 4 minus 12, and that's -8. -4 minus 4 again gives me -8. So the common difference, it looks like the common difference here is -8. So when I write my formula, it looks like each new term is the old term subtracting 8. So each term is equal to the previous term minus 8. And then I also have to make sure I include the number to start on. So this sequence, A1, is 12. There's my recursive formula. All right, so another example. Let's see if we can write the recursive formula for this sequence. Okay, this time, instead of being given the sequence, it looks like I have a formula. This is an explicit formula because it lets me find a n in terms of an n. There's an n to plug in here. So the first thing I kind of want to do is get a feel for what this sequence is doing. So let's just plug in some values to see what we get. When I plug in n to be 1, what does this sequence equal? Well, -24 plus 20 times 1, that's -4. How about when I plug in 2? -24 plus 40, it gives me positive 16. How about when I plug in 3? 3 times 20 gives me 60. 60 minus 24 is 36. Okay, so when I look at this sequence, it looks like every time what's happening here in the pattern is that it's adding 20. So I'm beginning to see that my common difference here, if I were to do this again, I would have 36 plus 20, 56. Okay, so I'm beginning to see that my common difference here is 20. Well, look, there's 20 in the formula. And it turns out that when we have an arithmetic sequence like this, that if you can think of this as y equals mx plus b, the slope of this, the 20 here, is the common difference. Okay, so the slope of 20 here is the common difference, and so each term is adding 20 more, so it looks like my sequence is going to be that an equals the previous term plus 20. And I must also say the number that we start adding it. In this sequence, a1 is 4, negative 4. So there's my recursive sequence that I just got using my explicit sequence. Okay, so here's another example. Let's see if we can write the recursive formula for this sequence. Okay, it looks like every time it's not going up by an even amount. The numbers are not getting bigger or smaller. Matter of fact, they're going between positive and negative values. We have a negative, then positive, negative, positive. I would assume the next number would be negative. So instead of subtracting to find the difference between the terms, this time I'm going to divide them. The common ratio between the terms is found by dividing them, and the ratio this time is 20 divided by negative 4, which would give me the same thing as negative 100 divided by 20. Pick any two and divide them, and you're going to get your common ratio to be negative 5. So it looks like for this problem that every term is multiplying by negative 5. So if I want to find the new term, what I have to do is take the previous term and multiply by negative 5. So what I have is negative 5 times the previous term. And I must also always say the one that I'm starting at. And so it looks like my A1 for this time is negative 4. All right, and there's my sequence. So the base is the common ratio, and we can see that in this problem, the common ratio is 4. It's multiplying by 4 every time. So now we can write our formula. The formula is going to be that the new term is equal to 4 times the previous term. Each new term is equal to 4 times the previous term. And I also need to say the term that I'm starting out with, my A1 value was negative 2, which can also be seen as part of the geometric formula sequence. Great!